We'll get us off the Fallout category here. Perfect. All right, so this is Starlink 6-52. This is launching from Cape Canaveral Space Force Station. This is Space Launch Complex 40. Booster first stage tonight is serial number 1080. It's its 7th flight off of a 28-day turnaround. This is moving 23 satellites into low Earth orbit, most likely flying on the southeastward trajectory. So 54 degrees.
Stage 1, lock load complete.
54 degrees inclined southeast out of the Cape. This is SpaceX's 40th mission of 2024. I don't know how many flights are on those fairings flight, and SpaceX doesn't tell us the serialized numbers of the fairings, but I know those fairings have flown. They have scuff marks on them, right? Like, T-minus 2 minutes. Right? The only clean part we ever see is an upper stage.
Stage 2, locks load complete.
Right? Should be getting up on ground gas closeout here. There it is. That's what that big puff of smoke is. They're evacuating all the propellants out of the
ground gas closeout.
See? Out of the fuel lines that go to the second stage. $60 seconds. Startup.
Falcon 9 is in startup.
Discovery, go at throttle up.
Purple Pie, 66 months. Thank you.
SpaceX Launch Director, go for launch.
LD, ports go for launch. 40 seconds.
T-minus 30 seconds. $15 seconds. T-minus 10, 9, 8, 7.
Different camera
6,
angle. Sound
5,
suppressor is on.
4, 3,
Ignition.
2, 1. Engines full power. And liftoff. Go Falcon, go Starlink.
Starlink 652 spreads its wings on this Thursday afternoon. Not available in your location. Sorry.
M1D, chamber pressures are nominal.
Good call
Vehicles pitching downrange.
from Flight Dynamics there. Should get a call from Ecom here in a second. The electrical people saying that the power is working. Yep, see, vehicle's rolling to the southeast trajectory. Southeast is this way. The camera is 90 degrees off the vehicle. Falcon 9's
Power and
flying that
telemetry
direction
nominal.
relative to the ground. Power and telemetry is good. I know, dudes. It's so freaking routine. I don't even know it, like... Sometimes I think,
Vehicle
like,
supersonic.
we would just watch. Got some high-level clouds there around 25,000 feet. Not over the launch site, though. Maximum dynamic pressure right there. Wow. They were just on the edge of those clouds, huh? I agree, Hypersonic. It never gets old, dude. Okay. In about 45 seconds, we should see main engine cutoff, stage separation, and second stage engine start 1, or SES1, happening very, very quickly. But until then, just enjoy the view. There is a radial out velocity component here. Note that the flames coming off of Falcon 9 are asymmetric. See how there's a gap right there and there's no gap over there? That's because the rocket's kind of going in this direction and it's pitched up a little ways. What's called a radial out velocity component. That radial out velocity component is boosting the apogee of their orbit. It's basically making it's pointed up higher so it can go higher. I know. Rocket science, right? Like, see how it leveled off for stage separation? You don't want to separate when the rocket is crooked relative to your oncoming velocity. Separation.
Stage separation confirmed.
There it is. Second stage engine start.
And back ignition.
SES1 on time. Very good. That first stage, 1080, is looking for a landing here on SpaceX's drone ship, a shortfall of gravitas, which should be happening in the next 4 minutes. Why do the space blanket bags puff
Bearing
up?
separation confirmed.
Bearing separation? Why did the insulative material puff up only after separation? Because there's gases venting inside of them. See, some of the gas is expanding into that area. If I can see the vents, that's a vent system right there. See the venting equipment? I mean, that and vibrations. The vibrations from the rocket engine are shaking them around a little bit. But the venting system, because gas isn't directional up there. It'll just actually I'm not sure that that's supposed to be doing that. Beautiful shot of the Floridian Peninsula, though, right there. There's Tampa. See it over there? It's upside down in that picture. The sun just might be backlighting it. How many launches for this booster? This is 7th flight. Relatively low comparatively. But see, yeah, there's all of South Florida right there. You could see a contrail from an aircraft right there. That's what that big straight line is. I'm not entirely sure that it's supposed to be venting like that, but I've watched so many of these launches, I don't remember if that's supposed to be there or not. Yeah, Hibbit, I remember. I think it just might be exacerbated because it's being backlit by the sun. Yeah, that's a vent line. It's a LOX vent line, and it might just stay open when there's propellants running through the engine. Because that one isn't on. See that vent? We can't see that one doing anything, but that one is. See, that one's going right there. These vents are connected to the turbine machinery plumbing, and they're used for thermal conditioning of the motor. Basically, they're priming vents. You could see the connectors for them are riding in that interstage. You see those wires that are moving around? Those are the connectors. Oh, yeah. It's being gaslit right now. This is the 7th flight for Booster 1080 here. See some solid nitrogen. Actually, that was just ice coming off the booster. First stage is getting ready for supersonic retropropulsion, where it slows itself down and protects itself from its own re-entry heating, with its own rocket
Stage
exhaust.
1 entry burn startup.
Ready?
Stage 1 FTS has safed.
On. 1 engine. 3 engines. See how the plume changed shape? Okay, full entry burn there. Yeah, the flames from the rocket motors are pushing the reentry heating away. That's how it doesn't burn up when it goes through the atmosphere. The best part. That's my favorite part.
Stage 1 entry burn shutdown.
Stage 2 FTS has safed.
What Krillani said then. Yeah, it's just the sun backlighting it. Yeah, that's normal. All right. So, yeah, the reason why these inflate, Flykin, is because some of the gases really aren't directional, right? Up in the vacuum, gases just infinitely expand in all directions, right? There's the end of that vent line, and they'll just infinitely expand. So when they turn the engines on, some of that gas goes up in the blankets and inflates them like that. Some of it. Stage 1, the Stage 1 camera's got a little funky right there. Oh, there we go.
Stage 1 transonic.
That shot is super delayed for that call. Oh. We have a loss of signal there on that first stage. Oh, there we go.
Stage 1
Re-updated.
landing burn.
Signal is very intermittent over there. See those numbers just kind of updating and then stopping and then updating again?
Landing leg deploy.
But we're still getting calls for the legs. And these aren't timed calls either. This is landing the person that called landing leg deployed. That's because they saw the
Stage
landing
1
leg.
landing confirmed.
Okay. See? They have better telemetry than we do. Interesting. Is there no communications blackout on booster reentry? Well, Jay, that's actually a super good question. So there's the trajectory. We should wait for a call for nominal orbit insertion at the end of SECO here, but they might cut the cast before.
SECO.
Okay. 27057 seems pretty on the ball. Hold on one second.
Nominal orbit insertion.
Good. All right, cool. So, Jay, the communications blackout doesn't happen because the antennas, the ground stations that Falcon 9 is communicating with, and specifically like the antennas on Falcon 9 are all up at the top. Reentry's happening at the bottom. And because of the way the way reentry propagates, right? If it was coming in this way, right, and our antenna was here, right, it would be tough for us to see it through the plasma. But since plasma accumulates, it doesn't like propagate, it accumulates, it stays there because the oncoming air gets compressed and holds plasma there. It accumulates. Think of it like if you have a cold snack on a warm day, how the water kind of accumulates on like the condensation accumulates, it stays there. Now, keep in mind, condensation is happening for an entirely different reason than plasma accumulation. One is from air compression. The other one is from condensation because atmospheric vapor condensation because of differential temperatures. But plasma just kind of stays there. It just kind of sweats, right? But it's very directional. Plasma is accumulating at the front of the booster. The booster's flying this way, right? Out the back, you got a clear line of sight. You can get a clear line of sight to your ground station back at the Cape. So that's how we can get some pictures most of the time. That time it didn't like that at all. The antenna wire for the cameras might be a little funky. Maybe it came unplugged, who knows. But yeah, that was a good question, dude. It was the same case for the space shuttle. When the space shuttle's coming in, right, there's a cone of plasma around it, but the plasma isn't directly behind the shuttle, right? So if NASA had a satellite behind the shuttle, like if the shuttle was re-entering right here and NASA had a satellite over here, you could get an uninterrupted signal because, yeah, the shuttle's antennas are on the top of the space shuttle. They're transmitting backwards to a satellite, bouncing off the satellite and bouncing back down to the Cape. So NASA can get uninterrupted signals through reentry. During the shuttle program, they were doing it for 20 years, Can you explain to me how fairings survive re-entry? Yeah, sure, man. Sure. You think you got a picture of it? Let me see, goalie. Yeah, I think you got a picture of it too. Yeah, Rick. So, okay.
Discovery, go at throttle
If
up.
I was at the top of the Empire State Building, okay, and I had, let me just find something. Okay, if I was at the top of the Empire State Building and I had my axe and I threw my guitar off the top of the Empire State Building, pretend nobody's down there, pretend nobody's below. You wouldn't want to get hit by this going terminal velocity. That would really hurt, right? So what's going to happen? The guitar is going to fall off, right? It'll probably end up stabilizing like this because this is the heavier side. When something is flying through the air, the higher mass side always flies first. The more dense part of it always wants to go first. So it'll probably end up doing this, right? And then it'll slam into the ground and break into a bajillion pieces. That's usually what happens with first stages if they come back down. That's usually what happens, right? Now, what happens if I have a piece of paper? Or better yet, a paper airplane. I'm up at the top of the Empire State Building. Now, in this analogy, pretend there's no wind. Pretend there's no wind. We have an ideal circumstance. There's no wind. It's not a windy day. You take the paper airplane, you throw it off the side. Say we cut some control surfaces in the back and bent them up so the thing just does spirals, right? So it'll just spiral around, and spiral around, and spiral around, all the way down to the ground, and it'll probably land just fine, right? We threw it off something that was the same distance as the guitar, right? But since that piece of paper is so dang light, not an issue. It'll just land. Like if you threw it from 20 feet as opposed to the top of the Empire State Building, right? Right? Fairings basically do that. They're super freaking light. They're super light. Like comparatively to, so, okay, we're going to get into some basic aerodynamics here, right? Fairings are, for their size, they are absurdly light. They have to be light because, well, the less rocket you have on your rocket, the further your rocket can go. So everything in aerospace and airplanes and rockets has to be super, super light. Low mass is the technical way to talk about it if you're saying rockets, right? So the fairing has an extremely big surface area, right? Like if you're just looking at the fairing coming down, like this is the fairing coming in, we were looking at it, there's a huge surface area. Now the ratio of the amount of surface area being exposed to oncoming velocity versus the mass of the object, right, it's a really big ratio. There's a lot of volume and not a lot of mass, just like that piece of paper, right? Same idea, same exact idea. So the fairing it'll just kind of coast through the atmosphere. It'll still experience some re-entry heating. Just like if we threw that paper airplane off the building, gravity's still going to push it down. It's still going to get some re-entry heating, but because it's so ridiculously light, it decelerates extremely fast. Right? Big volume, low mass. Or big surface area, I should say. Very low mass. What a cool channel. Ah, yeah. Notes, I'm a STEM streamer. I also been just on a big Fallout kick lately, but... So, yeah, the fairing is like throwing a piece of paper off the top of a building as opposed to throwing like a guitar off the top of a building. It's super light for the surface area and it just kind of just glides down. Have you seen this video of the fairings? Yeah, many times. So the mass influences the re-entry heat. Oh, absolutely. Sure. Yeah. Force equals mass times acceleration, dude. That's one of the basic laws of physics. Sure. Because the fairing is so ridiculously light and it can decelerate really, really quickly, right? The overall heating is not nearly as high. It'll still, don't get me wrong. There's some videos that people are linking in chat. The fairing still experience some re-entry heat, but, you know, if we're talking thermodynamics, right? Or thermodynamics, right? The materials that the fairing is made out of can absorb the heat before something bad happens. Let me put it to you like that. Yeah, no, it's more or less. That's why it's, yeah, exactly. you can aerobrake on Mars. You can use Mars's, albeit very thin, atmosphere to help you slow yourself down. On the moon, it's just, if your rocket engine malfunctions, you're going to be pain on the surface real fast. Any Kerbal player knows that. Makes perfect sense. Thanks for your explanation. Yeah, sure. No problem, dude. Can someone fact check this whack job? Yeah, right. They put parachutes on them. Actually, it's parafoils, guys. They put parafoils on them. So fairings actually have RCS on them already. They have little thrusters on them. Every fairing on every rocket does. The thing is, on a rocket like Falcon, or a rocket like Atlas, or a rocket like Delta, respect, the RCS just goes one way. Fairings, most fairings use a pneumatic separation system. So, right, when the fairing separation goes, the latches unlock, and then the RCS outgasses, psss, right, and it pushes the fairings apart. Most fairings use a pneumatic separator, right? Because you don't want to have like rocket engines in there pointed at each other and fire those things to separate it. That won't end well. Just a little bit of compressed air. Just psh. They usually use nitrogen or helium or whatever. I mean, it depends on how big your fairing is, what kind of impulse you want to get out of that separation, how much thrust you like. You obviously don't want to outgas like into a payload, right? So fairings have a pneumatic system. They have RCS on them kind of already. Now, SpaceX took it one further, right? Instead of just having the fairing shoot RCS in one way, they can shoot it in different directions. They have RCS blocks on them. So they could shoot the RCS, this compressed gas, sideways or up, right? Or down. And you could, because of that, because they have blocks, the blocks are used for separation, right? And then the remaining RCS is used to steer those fairings. Those fairings have some attitude control during reentry, so they make sure they reenter backwards, so with the skin of the fairing on the outside, right? And then when it makes it through the atmosphere, it'll deploy a parafoil, right? And that parafoil it'll glide down, believe it or not, and do circles, just like that airplane, just like the airplane analogy. That's exactly why I use that analogy. The parafoil will deploy, and the thing will just glide around. It'll just glide around, and it uses the thrusters to steer it near one of the recovery ships, and guess what? It just lands like a seaplane. Straight up. No, Brunheen, I know. I've seen you in here many times, dude. Don't worry about it. Yeah, here. There's actually some footage of that, not fairing reentry. There's actually some footage around here of that was actually super freaking recent that I can show you guys real quick. This was filmed by a fishing crew. I gotta find it. It's on Twitterers somewhere. Give me 1 second. Yeah, here, check this out, dudes. Want to see? This was filmed by some fishermen off the coast of Baja, California. Look, see? There's the parafoil. Check that out. See? There's one of the fairings from the Vandenberg mission that we watched the other day. It's just coming down, and see? Another way you can tell these fairings for their size are extremely light is look at where the draft is on that fairing. Anybody know anything about buoyancy, right? Look at how much of the fairing is in the water versus how much of the fairing is out of the water. Those things are insanely light for their size. Like our paper airplane analogy. See? Look at that thing. And oh, see that? There's your pneumatic control systems, and look at these lines. There's your pneumatic lines. They look like brake lines on a car. Actually, the squiggly parts are the wiring for the solenoids that control the valves, right? How do I know that? I'm a nerd, okay? It's my job to know that. And then you have your 3 composite overwrap pressure vessels that have extremely high pressures of gases in them. SpaceX uses nitrogen for these, if I'm understanding this right. And then I do believe we have pressure regulators there. But yeah, what a cool stream. Keep going. Keep going. I'm going to come here more frequently. Very informative. I'm a rocket fan. Keep rocking. That's what I do. Notes, I've been doing this for a decade. But yeah, and these things right here, those guys on the sides, these kind of things that look like portholes, that's your latching system. And then they have a guide rod. One side of the fairings has guide rods. You can see them right there. There's another one up there that it's kind of hard to see. But see, there's your latch mechanism. So they'll, you'll send an electric signal to the latches undo, and then like a fraction of a second later, you start pulsing the thrusters and the fairings, they fly off. A decade, geez, you're old. Yeah, I know. Right there, those are your fairing vents. On your way up, all the air, because you're under acceleration, the air is still mass. It'll get pushed to the bottom of the fairing. Think about it like liquid in a glass. And if you don't have vents down there, your fairing will pressurize. You don't want your fairing to pressurize because when you go to separate, that extra gas pressurization could push your fairings in a way that could hit the satellite. So every spacecraft that's designed to move cargo has a positive pressure vent. There's 2 of them right there, and then there's 2 more on this side. See them right there? Those are your pressure vents. That's on the way up. All the gas inside of there, all the atmosphere, because they closed it. They didn't depressurize it when they closed the fairing. On the way up, all the gas just leaks out the sides. Fun fact, everything has that. Like even the shuttle. The shuttle's payload bay was not pressurized. And if you look very closely, there's vents on the side of the shuttle's payload bay. See? 1, 2, and 3. Same idea. Same thing. Even the space shuttle has those. This thing's not designed to go in water like the fairing is, though. You don't want that. That is, in fact, not a boat. That would be bad. I'm really happy that never happened. I swear, Notes, if you say they plan it, I'm going to be a little upset. Yeah, they plan it. Yeah, okay. Okay. Would the shuttle float or sink? It would sink. Very quickly, talkative. Those tiles on the shuttle were notorious for trapping water. So the shuttle's thermal protection system, if it ever did hit the water, would basically become a giant sponge. That would be pretty bad if you were inside of it when it happened. Yeah, that would be bad. Yeah, that's why the tiles fell. That's why the tiles initially at the beginning of the space shuttle program, that's why they fell off. Because they built the orbiter out in California where it's not humid, super dry, flew the dang thing to Florida where it's not dry, it's humid all the freaking time, and it rains a lot. Now, I don't think it ever rained on the shuttle, but the tiles could absorb humidity out of the atmosphere and trap water inside them. And the glue that they glued on the tiles with at the very beginning of the shuttle program was water soluble. Oops. So all the tiles fell off. Delayed the shuttle program by 2 years. Seriously, that happened. Whoops. Oh yeah, shuttle densification. Oh yeah, delayed the shuttle program by 2 years. Shuttle was supposed to fly in 1979. Didn't fly till 1981. I saw that NS post. I'm not sure. NS. Anyway. Yeah, lesson learned. Don't use Elmer's glue to assemble your space shuttle. That's right, bro. Anyway, let's jump back over to Fallout 4. We're working on a logic problem in Fallout using the Contraptions DLC. I'm going to pop back over.